All right, welcome back. We're here on section 7.6, and we're going to be talking about the natural base, which is E. E is actually a number, kind of like pi. What it kind of bases on is that, if we look at compounding interest, let's say that we had an interest rate. Would you rather get 12% at the end of the year, or would you rather get 1% per month? Well, the answer is that you'd want to compound at 1% per month, because then the more times you're able to compound that interest, the more chances you have of growing your money. Because not only is the principal amount getting money interest on, you're getting interest on the interest. So the more times you can do that, the better. So what happened is that they decided, okay, well, let's see if we could do it not just every month, but every week, then every day, then every hour, then every minute, then every second. And then they got to the idea of working towards, what if it just happened continuously? And it kind of reaches a limit is what it gets to. And what they found is that if you took 1 plus 1 divided by n and then raised to the nth power, it actually approaches a number that's about 2.71828. It doesn't repeat, kind of like pi. So they decided to call that E. You see this a lot in business sense and the things is this number E is what it is. So it's about 2.7 if you want to think of it as a number. All right, so that E to the x power looks like this. It's, base is E, so it's close to like 3 to the x power, but it's still like 2.7 to the x is what it is. And you can use that in a lot of financial type of things. So as we kind of look at this, if we do e to the x minus 3, we know that moves it down 3. You can look at graphs, all those fun things. And you'll see that on your calculator, the E button that you'll have. You can always do that. Now, if we're going to use that now as the inverse of E, it's a log base E. But much like what we do with common logs, with base 10, we just do log. We're going to use ln, which means natural log. Why not NL? Well, log, that is natural. ln is kind of what they do. So that's the inverse of that e to the x button. Okay, so everything that we've learned so far applies. It just means that the base is e. That's all it is. It's the only difference, what we have. So, we have here, we're kind of just looking at the properties. All those that we learned in 7.4 apply. So let's look at some of those. So we know if it's natural log, ln, it's just basically saying e to what power is e to the 0.15. Well, it's 0.152 then. This one over here, again, what I would do is move that 3 so that it's over here. You can put that back over there. So the e to the natural log, that's log base e, those cancel each other out is what happens. And so that's what you get there. All right, remember your other properties as well is that if you have the natural e, the log base e to what power, this actually turns into 2x. This just turns into x. And so you can add those together. Remember, ln, if you have ln, that really is log base e. That's what it is. Okay, so keep that in mind as we're working forward to all these different properties, of course, that we've had and we've seen. So let's kind of get into where E is used a lot. And this is the formula that we're going to be looking at. Again, highlight this in your notes. It's a way to compound. It's a way to figure out interest if you're compounding continuously, which is what you want to do. You want it like every time you blink an eye, it's compounded. You don't want to wait a week. You don't want to wait a year, because it's more advantageous for you to compound as many times as possible. So this will give us the most interest that we possibly can get. With small amounts of money, it doesn't matter that much, but when you're talking large amounts of money, it's pretty significant. Okay, so I think of it, I always remind it as A equals PERT, PE to the RT. P is the principal amount, which you start with. R is the rate as a decimal, and T is your time in years. Okay, so if we're going to set up problems like this, here's an example. What happens if I take $500, invested at 5.25% interest for 40 years, and compound continuously? Well, you'll notice that we put the 500 in for P. E is just always part of that. R, we put it as a decimal, so it's 0.0525. And then years is 40. And then we type it in the calculator. And we figure out, after 40 years, it grows to $4,083.08. And that's without even adding anything to it, just letting it sit there. They call that letting your money work for you instead of you for your money. So let's us set up one for ourselves here. Let's see what we got here. We're going to take $100. We're going to invest that 3.5% interest for 8 years and see what we get. Okay, so once again, the original amount, the principal is 100. We're going to go e to the r, so remember that's going to be 0.035. I always write it as a decimal. And then the number of years, 8, is what we're going to get. All right. Well, let's see if we can't put that over here into the calculator. Let's take 100 and let's see times, and then see that little E button. We have to hit second and then hit that E button right there. And then we're going to go point, I'm going to put parentheses. I'm going to go 0.035 times, I'm just going to put that here, times, was it 8 years? I'm just going to kind of do it like that. And look at that. We do get the $132.31 is what we get. So that's how we type that in when we go to the calculator. So remember that E button right over the natural log, which is the inverse, kind of makes sense. You see that button over there. So, all right, so there it is. That's kind of what we're working on. All those same properties, remember, hold true. Again, so when you see the natural log, remember that just means log base E. That's all it is. Okay? All right, so have some fun with that, 7-6. Until next time, I'm Mr. Moon.